Let's talk about division. Here you're given a problem that's been started and you're asked to determine what number should be placed in the box to help complete this division problem. So what's missing here? My suggestion whenever you're analyzing another person's work, something that's been given to you, is to do the problem on your own. So here we are dividing 9,358 by 15. So I'm going to come out to the side and I'm going to start off just by walking through the steps of how I would do that. And then I can compare that to what they did. So with division, our process is repetitive. We're going to divide 15 into 1 digit, 2 digit at a time until we are able to divide. So for example, 15 does not divide into 9. And placement matters. So I'm putting a little X there because you're definitely not going to have 15 dividing into the thousands place. So we're going to move over and include both the thousands and the hundreds place. So we have 93. 15 does divide into 93. So how many times does 15 divide into 93? We're going to put that answer above the 3 because we used both the 9 and the 3. So that's the hundreds place. So really 15 divides into this number 600 times because that's the hundreds place. So there's the division. Now we're going to multiply. 15 times 6 is 90. That's how I would do it. Now these extra zeros over here come from multiplying by the place value as well. So rather than just saying 15 times 6 is 90, 15 times 600, since this is over the hundreds place, is 9,000. So I could do it that way. And then my next step is subtract. When I subtract 90 from 93, I get 3. And then I always say the next step is to bring down because we'd be bringing down the next digit, which is a 5. And then we start back over the process. Divide. 15 divides into 35 2 times. This time we're using the 5, so the 2 goes above the 5. And that 5 is in the tens place. So 15 times 2 is 30. But notice they didn't just include the 15 times 2, just like they did with the 9,000. They're multiplying by the place value as well. So when we subtracted 9,000 from 9,358, we get 358. And then when we multiply 15 times 20, since the 2 is above the tens place in our dividend here, the 2 is above the tens place, so that's 20, 2 tens, 20, 15 times 20 would be 300. And then when we subtract, we get 58. Well, we get 5, bring down the 8 if we're doing this without using that place value. But if we just subtract 300 from 358, we get 58. And now we can continue dividing. But we do see what goes into that box. It would be 15 times 20 since the 2 is above the tens place, and 15 times 20 is 300. To continue dividing this, 15 does go into 58 3 times. 15 times 3 is 45. And notice we did not get 0 here. We actually got 13. So that would be considered a remainder, meaning 15 does not divide into this number equally. So moving forward, you'll express these answers as either a decimal or a fraction. If we were going to use a mixed number, we could stop now. We know the mixed number is 623, and we always put the remainder over the divisor. So 13 over 15. That would be a mixed number. If we wanted to continue by putting our decimal and then adding as many zeros to that 9,358.00, we can put as many zeros there as we want, then we could continue dividing. Bring down a 0 and keep dividing. 15 goes into 130 8 times, and 8 times 15 is 120. So I divided, I multiplied, now I need to subtract. I get 10, still not a remainder of 0. Bring down the next number, 0. 15 goes into 100 9 times. Nope, sorry. 6 times. And 15 times 6 is 90. And then I subtract and get 10. And then I can bring down another 0. And I'm at 100 again. So 15 goes into 100 6 times. I'm going to get that again. And then I'm going to multiply and get 90 again. And then I'm going to subtract and get 10 again. Then I'm going to bring down the next 0. And I'm at 100 again. 15 goes into 100 6 times. Again, obviously, this is going to go over and over and over in a repetitive pattern, which is what leads me to the decimal 623.8. The 8 didn't repeat, but the 6 did. So just put the bar, the repeating bar over the 6. And now we have our decimal representation of this quotient.